Good morning and good afternoon, sixth grade, and welcome to part 2 of Computers and Peripherals. Yes, ask the average sixth grader to say the word peripherals 3 times fast, and it's going to be a funny thing. And if you're watching this video going for peripheral, I got you. All right, so let's continue on with the lesson. I'm not going to summarize what we spoke about before. I'm just going to go ahead and hit the ground running because you could go ahead and rewatch those videos. Now, what this slide is dedicated to is storage, specifically storing data or data, however you want to say it. And computers usually store data in various ways. Modern computers and modern smart devices such as tablets, smartphones, and what have you use certain technology that you probably would not find. Let me phrase that. You could find on a laptop or a system unit, but you might not, depending on how it's configured. Each desktop is a little bit different. So the first thing I want to talk about here is the hard disk drive. This is older technology, and basically what you have here is you have these little plates that house the data. It reads and writes information via magnetism, and it writes the ones and zeros or the data on these disks, and these disks spin. And then as these disks are spinning, there's a little arm that goes across and reads the data. Now, the cool thing is that this is older technology and cheaper technology, and therefore you can it costs less per byte of storage. Okay. Now, more modern devices and higher end units use a solid state drive. A solid state drive stores massive amounts of data, but instead of writing it magnetically and having moving parts, it doesn't have moving parts, therefore is a little bit more reliable, and it reads and writes data electronically. So it's much faster and much more efficient, and it is more reliable. However, there is a cost to these. These tend to be a little bit more expensive to store data on per byte. Now, remember that computer I was telling you that I built for my media and media creation? It is filled with these type of drives on here, not those types of drives, simply because of the speed and reliability. Now, older technology uses optical. Optical means it's read by something with a lens on it, all right? We talk about optics with our eyes. You go see the optometrist, okay? But in this case, it's read and written by laser, okay? So there's a little disc in here that has tin that's burnt in for the ones and the zeros or the data. And if you were to actually look at the side of the disc in here, you would see little bumps and rises representing that 1 and that 0, okay? So these include things like DVDs, CDs, and Blu-rays, and others. Not too many people use these anymore because of internet and internet speed and flash media, but you still see those around in some cases and such. And of course, there is flash media, which we know is very portable. Now, this one happens to be a micro SD card. And of course, we saw another flash media device in another slide. Some people use the term memory stick. That's incorrect. That's something that's owned by Sony. We don't make those anymore. But basically, it reads and writes just like the solid state drive because there is no moving parts to this, and it doesn't require this disk to spin or be read by a laser. So again, to paraphrase everything, hard disk drives, right? Older technology, less expensive per byte, but more prone to breaking down. The solid state drive is faster, more efficient, but more expensive. You have older technology here, writing CDs. This has moving parts and is written by laser. And then, of course, you have your flash media, which works very similar to solid state drives. Now, other parts of a computer. You see, the computer operates by many, many different parts here. So first thing I want to talk about is a power supply. A computer does not like power straight from the wall. And if you were to put that power from the wall to the motherboard, it would go crazy. It wouldn't work, okay? I'm not going to go into the electronics behind it, but basically what this does is it converts household power, or what comes out of your outlet, into regular usable power for the computer, okay? So it converts that household power into useful system power. Um, now, uh, the motherboard, okay? The motherboard is basically the backbone of the computer, okay? It allows the computer to communicate with other things that are connected to it. We'll use the term peripheral, okay? So it allows the CPU, which will stand for Central Processing Unit. I'm going to talk about that here in just a few minutes, to communicate with all the parts it needs. Looking at this, and I'll probably pull a demonstration out later on in class, but right here is where the CPU goes. This is where the RAM goes, okay, the random access memory. And then you have other cards like video cards and networking cards that would go up in here. And these are the ports up here where you plug in your mouse, keyboard, and such. The power supply plugs in on the side over here, and sometimes other ports in the middle to get and deliver and distribute its power. And of course, that happens over here as well. Alrighty, now, the motherboard might have software built into it, okay? The software that's built into a motherboard is called ROM, or read-only memory, but more specifically, the software to help run the computer and tell the motherboard what to do and such is called the BIOS, the Basic Input-Output System. It's the software embedded into the motherboard that helps the motherboard work. All right, it basically wakes the computer from a cold start and is used during the boot or startup process. Okay, all devices, all smart devices have some form of BIOS built in, or else it would not know how to operate or how to communicate with the other components. Now, CPU, some people say that's the computer. That is incorrect. CPU stands for Central Processing Unit, and basically it's the worker of the computer. Yes, it interprets and performs the basic functions that operate a computer, okay, but it can only do what it's told to do by the underlying software. So the software tells it, okay, computer, I want you to calculate this. Okay, the CPU does that. Okay, computer, I want you to calculate or to perform this function. I want you to send this to this through the sound card. Okay, the CPU performs that function. All right, and it's doing it very, very fast. Okay, I may not talk about megahertz or gigahertz in this unit, but basically it performs it at various speeds. Older computers, not so fast. Modern computers, very fast, very efficient. All right, the biggest takeaway is CPU stands for Central Processing Unit, and the Central Processing Unit basically does not the thinking, but performs the work. Okay, it can only do what it's told. It can't think for itself. Now, as I mentioned before about BIOS, BIOS is read-only memory. It's the permanent memory that's built in, and you're not really supposed to change the memory. So anytime you might have a phone problem and you flash the ROM, or you go ahead and do some repairs that involve correcting some of the ROM, basically what you're doing is you are rewriting the ROM in the background so that the phone or device can operate properly. Okay, that could also be done in these computer systems as well. Now, another type of memory is what they call random access memory. It's memory that's used as needed and can be written and changed as needed. Okay, random access memory. And these are components that usually store or house temporary instructions and data on the computer. Okay, now on the BIOS is usually a little chip on the computer. It's housed inside the little chip. It might be up there or it might be up there, depending on the motherboard. But the RAM always sits in this area right here of the motherboard. And you can see, here you go, you got the CPU that sits in this box right there, and there's what a stick of RAM might look like. All right, we got a few more minutes left, so let's go ahead and cover this section. A peripheral, you heard me use that term. A peripheral is any piece of hardware connected to the motherboard. Anything. It could be a card, it could be a keyboard, it could be a printer, it could be speakers. It doesn't matter. If it's connected to the computer, either by USB or through other ports, it is a peripheral. All right, even if it's wireless, there's still something that's connecting to it. All right, even if it's Bluetooth, it's still a peripheral because it's connected using Bluetooth technology. All right. Now, other peripherals that are important about a computer to know is the network interface card. A network interface card allows computers to talk to other computers. Of course, you know that today. You have wireless network interface cards, the Wi-Fi. All right, allows you to communicate with Wi-Fi systems to allow computers to connect with other computers. Okay, we often call them NICs. Okay, in the internet technology world. Alrighty, next one we got sound card. Sound card basically handles all the audio related functions. You see, computers don't understand audio like we understand audio. It doesn't understand frequency like we understand frequency. So what a sound card does is it converts data into something that you and I can understand. Sound, okay? And it takes what we usually record and usually put into a system, and then it outputs that back to us. Alrighty? And then, of course, finally, you got the video card. The video card, if it's separate, converts visual information into graphic data for the monitor. Now, some video cards are built into the CPU on modern systems. It really depends on how the system is designed, okay? But in this case, you have an external component that connects right in with the computer or the motherboard, as I showed you earlier on the other slide. All right, so if that's confusing to you, here is a real easy way to think about it. I want you to think about the insides or the parts of a computer like an office, all right? So the parts function and work together like somebody would be working in the office, all right? Inside of an office, you're going to have a worker. That worker is the CPU. It is basically doing the functions that's asked of it, okay? Computer has storage. So those in an office would be things like storage cabinets or like these bookshelves, okay? It's storing the information or keeping the information or housing the information. Now, ROM would be equivocal to say like instruction manual. And that might be like this bookcase up here that has a basic set of instructions for what the worker needs to do. Hey, worker, the light's over here. Hey, worker, the phone's over here. Hey, worker, your desk is over here. Hey, worker, there's a filing cabinet here and over here, and it looks like there's some storage over here. Hey, worker, there's some information over here that you might want to consider, okay? Now, random access memory can be thought of as the desk of the computer. If you have a small desk, it's very hard to perform multitask functions. In other words, do a lot of things at one time. However, if you have a larger desk, it's easier to perform those functions. So the more memory you have, or the more random access memory you have, the more you can do at one time, with the limitation being, of course, of what the actual CPU itself can perform. And of course, sometimes that RAM is actually done by the hard disk drive, or the solid state drive. And of course, for communication, you have phone, and of course, the lights kind of show the worker where everything is at. All right, so on your activities, you have 2 slides. You got a question here. What's the difference between ROM and RAM? Which device allows computers to communicate with other computers, and approximately how many characters of data are in a megabyte? You'll have to refer back to the first lesson for that. And then there's a slide B. Which component handles the sound? Which component handles the video? And of course, which component is considered the worker of the system unit? All right, guys, that brings me to the end of this presentation, and I hope you picked something up from it.